going by the formula, number of moles equals to number of ions all over Avogadro's constant. From the question, it is given that the number of mole is 1.46. Number of ion is what we are asked to look for. And Avogadro's constant is given as 6.02 times 10 raised to power 23. To get this number of ions, you make number of ions the subject of the formula by cross multiplying these two entities. Then you have number of moles. Number of ions equals to 1.46 times 6.02 times 10 raised to power 23, which is equivalent to 8.79 times 10 raised to power 23. Therefore, the number of ions is equal to 8.79 times 10 raised to power 23. Therefore, the answer to the number of ions in question 2 is equal to 8.79 times 10 raised to power 23. Question number 3. What volume of oxygen at STP will be obtained when 24.5 gram of potassium triacylchlorate 5 crystals is heated? Given that oxygen is 16, potassium is 39, chlorine is 35.5. Looking at this question number 3 closely, you will find out that it is the number of volumes that you are asked to look for. So the first step here is to indicate that number of moles equals to mass of substance. Mass of substance all over molar mass. Molar mass of potassium triacylchlorate 5 is equal to potassium from the question is 39 plus chlorine from the question is 35.5 plus oxygen from the question is 16. And since you have 3 atoms of oxygen, then you have 3 into 16. Solving this, you have 39 plus 35.5 plus 48. Now, if you add all this together, you will have 122.5 gram per mole. That is the molar mass of potassium triacylchlorate 5. Then the next step now is to now look for the number of moles. Number of moles will now be equals to mass of substance. What is the mass of substance from the question? It is 24.5 over molar mass. Molar mass has been calculated, and that is 122.5. If you divide 24.5 by 122.5, you will have 0.2 moles. Then the question asks you to look for the volume of oxygen. Remember that there is another formula that states that number of moles is equal to volume all over gaseous molar volume. GMV, gaseous molar volume. The gaseous molar volume is a constant. Number of moles has been calculated to be 0.2. Automatically, you impute the known parameters into the formula. If you impute the known parameters into the formula, then you have number of moles, which is 0.2, volume, and that is what the question asks you to look for. Then gaseous molar volume is another constant, which is 22.4 dm³ at STP, standard temperature pressure. Then if you are looking for the volume of oxygen here, you cross multiply. When you cross multiply, then the volume of oxygen automatically will give you 0.2 times 22.4 dm³. And when you multiply 0.2 by 22.4 dm³, you will arrive at 4.48 dm³. Therefore, the volume of oxygen is equal to 4.48 dm³. That is the answer to question 3. Back on the questions based on gas laws. Number 1, what is the volume of oxygen required to burn completely 45 cm³ of methane? Question number 2, 20 cm³ of carbon 2 oxide as packed with 20 cm³ of oxygen. If all the volumes of gases are measured at STP, calculate the volume of the residual gases after sparkling. Number 3, determine the vapor densities of the following gases from the given data. A. Sulfur 4 oxide. B. 560 cm³ of oxygen weighing 0.8 gram at STP. Question number 4. Under the same conditions of temperature and pressure, hydrogen gas diffuses 8 times as fast as a gas Y. Calculate the relative molecular mass of Y when the hydrogen is 2. Solutions. Number 1. What is the volume of oxygen required to burn completely 45 cm³ of methane? This has to do with combustion. And since methane is hydrocarbon, there is a formula for the complete combustion of all hydrocarbon. And it is written CX plus S plus Y over 4 into brackets O2, that's the combustion, giving you X CO2 plus Y over 2 H2O. This is the general combustion reaction formula. Now, based on CH4, which is methane, here your X is 1, while your Y is 4. Then, if you go by the model that you have on the board, you will have X is 1 plus Y is 4 over 4 to give you O2. Then X is 1, so instead of this you can write CO2, 1 stand for X, plus Y is 4, 4 divided by 2, H2O. If you simplify this equation further, then you will have CH4 plus 1, 4 over 1. 4 over 4 is 1. 1 plus 1, 2. That is now 2 over oxygen gas, which is equivalent to CO2 plus 4 divided by 2, that is 2. That's 2 water. So the equation for this reaction is balanced. From this equation, you can deduce that 1 mole of CH4 is equivalent to 2 moles. Is equivalent to 2 moles of O2. Look at the question number 1. The question says that what is the volume of oxygen required to burn completely 45 cm³ of methane? From this equation, you see that 1 mole of methane is equivalent to 2 moles of oxygen gas. Therefore, 45 cm³ of methane, CH4, will be equivalent to 90 cm³ of oxygen, since you have 1:2 ratio for methane and oxygen. So if you have 45 cm³ of methane, it will be equivalent to 90 cm³ of oxygen. So the answer to the question is 90 cm³ of oxygen. So answer to question number 1 is 90 cm³. 90 cm³ of oxygen is the answer to question number